All right. We are in section 6.5 where we are going to graph square root and cube root functions. Just like all of the other functions we've had through the course of mathematics to this point, each of them has what is called the parent function. I said this with quotation marks in my hands. And this doesn't change for either f of x equal to the square root of x, or y equals the square root of x, or y equals the cube root of x. And the parent function for if f of x equals the square root of x kind of looks like this. And the parent function of the cube root of x kind of looks like something like this. Okay? The reason why it stops right here at 0 is because x cannot be a negative number. We get an error code if we try to take the square root of a negative number, so that's why it stops there. We could use negative values if other parameters present itself, but like for this case here, we're just going to find positive values of x, starting with 0. So let me just take a few more values. Let's just do 1, 2, and 3. And to save you time, what you're basically doing is you're substituting in these values in for x to see what we get for y. And if x is 0, y is 0. If x is 1, my y is negative 4. If my x is 2, my y is something like 5, negative 5.7. And if my x is 3, my y is like negative 6.9. So if I plot these points, if I go to 0, 0, and then 1, negative 4, and then I got 2, negative 5.7, so something right about there, and then if I got negative, I got 3, I get like negative 6.9. So something kind of like this. So if I connect the dots, my graph kind of looks something like this. And if you're concerned with domain and range, my domain, which is the set of x values, for this one would be all, so it would be like x would have to be greater than or equal to 0 for my domain, and then for my range, for my y values, it would have to be less than or equal to 0. So you're going to get negative values here. Same thing for b. Can't use any negative values for x, so I'm going to use the same 0, 1, 2, and 3 to help me out. And then if if x is 0, my y will also be 0. If my x is 1, my y would be like 1/3. Let's just say it's 0.33. If my x is 2, my y will be positive 0.47. And if my x is 3, it'll be like 0.57. So it's not going to rise up too quickly. So if I go 1, 0, 0, 1 and 0.3, 2 and 4.7, 3, something like this. So it's kind of like going to be like a slow mover that'll rise up. But my domain and range, my domain here will have to be x is greater than or equal to 0. My range here will be y is greater than or equal to 0. Now, if we're looking at cube root functions, we can use the negative numbers here because the negative cube root is an acceptable value. It gives us a real number. So I can use negative values here. So I can say like negative 3, negative 2, negative 1, 0, 1, 2, and 3. And to save some time, if I were to substitute in x values, like say for negative 3, my y here would be like negative 7.2. If it was negative 2, it'd be negative 6.3. If it was 1, it would be negative 5. If it was 0, it would be 0. If it was 1, it would be 5. 2 would be 6.3. And if it was 3, it would be 7.2. So I'm going to plot these points. So I got 1, 2, 3, and then 1, 2, 3, 4, 5, 7. So something's on right there. 2 and like 6.3. Say it's right there. 1 and 5. 2, 3, 4, 5. Something like that. And then I got 0, 0. And again, 1 and 5. 1, 2, 3, 4, 5. 2 and 6.3. So something like that. And then 7 and 7.2. So if I were to kind of like make a look something kind of like that. Okay. Looking at B, again, make my t-chart, and I can use negative numbers. So I'm going to go negative 3, negative 2, negative 1, 0, 1, 2, and 3. If I were to substitute in negative 3, my y would be like 0.36. Negative 2 would be 0.31. If it was negative 1, it would be 0.25. 0 would be 0. My 1 would be a negative 0.25. This would be a negative 0.31. And this would be a negative 0.36. So again, this one doesn't really move all that slowly either. So if I go negative 3, this would be about positive 3.1. 3.6, this would be 3.1. Quarter, 0, 0. Would be what, negative 0.25, something kind of like this. And if I were to make my line, it would look something kind of like that. This is just a rough sketch. Last thing would be to talk about translations of radical functions. Now we've seen the shifting of other functions in sessions past, and they still mean the exact same thing. So A represents whether we're going to have a vertical stretch or vertical shrink of our function, depending on if A is the absolute value is greater than 1, or if it's in between 0 and 1. If it's in between 0 and 1, we're going to have a shrink. If the absolute value is larger than 1, we're going to have a stretch. Then when we're talking about x minus h, the h tells us the horizontal shift, and the value, whether it's negative or positive, it's going to tell us the opposite sign is where we have to move it. So if it's x plus 3, that means we have to move it 3 units to the left. If it was x minus 3, we'd have to move it 3 units to the right. Now for k, that whatever sign it is, that's the way we move it. So if it was plus 3, we'd move it 3 units up. If it was minus 3, we'd move it 3 units down. Okay? So looking at this equation here, I want to find y equals 3 times the square root of x plus 1 minus 2. So I want to find where that starting point in my graph. So if originally it was at 0, 0, but here it's going to have a shift of 1 unit to the left and 2 units down. So this is where my graph's going to start. It's going to start at coordinates -1, -2. So when I'm making my t-chart for x, I can start with -1. And then I can go up from there. So I can say, let's just go 0, 1, and 2. So if my x is -1, obviously it should be -2. So, and that makes sense because -1 plus 1 is 0. The square root of 0 is 0. 0 times 3 is 0. 0 minus 2 is -2. So that makes sense why this is where it starts. And if x is 0, my y will be 1. If my x is 1, my y is 2.24 roughly. And if my x is 2, my y is roughly 3.2. So if I plot these points, so if I got 0, it would probably be, what, 1. If I have 1, it's like 2.2, so 1, 2, so somewhere right about here. And if I had 2, it's about, so it's something like about like this. That's my graph. And the last one, if I do cube roots, here, there's no horizontal shift because there's no, h is 0 in this particular function. But my k is at -1, so that means I'm shifting it down 1 unit. So my x is 0, so I can still use the same values that I was given, that I could use. So I'm going to use -3, -2, -1, 0, 1, 2, and 3. And if my x are those values, my y here is roughly 1.88. This one for -2 would be 1.5. If it was -1, it's 1. If it's 0, it's -1, which makes sense because that's where my point starts at. If it's 1, it's going to be -3. If it's 2, it's -3.82. If it's 3, it's something like -3.9. So if I plot these points, so I got -3, and then it's like 1.8, so it's something right there. -2, 1.5, -1 and 1, and 0, -1, 1 and -3. So if I got 2, and then it's like really close to 4, and so is 3 is really close to -4 there. So if I were to make this, so it would look something kind of like this. Okay? And that is being able to graph square root and cube root functions. Hope this helps. Until next time.